Welcome to our seminar about AWS Well-Architected Framework, and we will speak about how to get the most of the framework. My name is Ilya Reznikov. I'm CTO Europe in Svitla System. So, before we begin, I would like to say several words about Svitla System, the company which presents this seminar. So, Svitla System is a global digital solution IT company, and we have been on the market more than 20 years already. Svitla System headquartered in California, but we have many locations around the world, in Ukraine, in Europe, in Mexico, in Argentina, and some other countries. We have reached more than 1,000 highly skilled engineers and already completed a bunch of projects in different industries. Also, Svitla System is an AWS Advanced Tier Service Partner. This title refers a designation within AWS Partner Network, APN, which is a global partner program offered by Amazon Web Services. It means that we have a strong team of trained and highly skilled certified technical individuals who have proven customer experience and demonstrate high level of technical proficiency and expertise in designing, implementing, and managing solutions on AWS Cloud. We provide the services in different areas, so application migration, application modernization, FinOps services, implemented DevOps practices, and also providing managed support services. Today, we will speak about AWS Well-Architected Framework, how it could be applied to your workload, about its outcomes such as risks and opportunities, and conduct practical case studies of two pillars. If you already attended our previous seminar, it was devoted to such pillars as cost optimization and security. Today, we will speak in details about reliability and sustainability. But let's start with actually what is well-architected framework. So please answer the first poll question. Are you familiar with AWS well-architected framework? Oh, by the way, chat is fixed, so you may send questions either to chat or comments to chat and questions to Q&A window. Okay, thank you for answers. Let's, okay, good. Thank you for answers. So I see that some of you already familiar with AWS Well-Architected Framework, and I hope I will provide you maybe more details on some particular things. For those who are not really familiar, if you will have some additional questions, please send them. So let me start with definition. AWS Well-Architected Framework helps cloud architects design, build, and operate a reliable, secure, high-performance, resilient, efficient, and sustainable infrastructure for a variety of applications and workloads. It means that AWS Well-Architected Framework provides consistent set of best practices for customer and partners to evaluate architectures and provide a set of questions we can use to evaluate how well an architecture is aligned to AWS best practices. I need to note that actually AWS well-architected approach is actually cloud agnostic, and it could be applied to workload deployed to any cloud, to hybrid clouds, to hybrid workload, and even for on-premise deployments. But obviously, it works better and more efficient if we consider AWS cloud architectures. And because, for example, it could be integrated and with various AWS managed services, as for area where we may improve our workload, and or, for example, with AWS Trusted Advisor, which gives more details about our implemented best practices. How and actually why AWS well-architected approach works. So first, framework can help build and deploy faster. That gives obvious benefits to business. We may achieve this by reducing unplanned actions, increasing capacity management, and using automation. This will empower us to experiment and release value more often. Also, we may lower or mitigate risk because if we understand some risk in our architecture, we could address them before they impact the business and distract our team from current work. The more information we have, the better our decision will be. So by ensuring that we may active and correct efficient architectural decision, we make control impact on business outcomes, and it means that we can make informed decision about future of architecture based on where are we today. And also, this approach allows us to learn best practices according to AWS, because these best practices has developed by reviewing architecture of 1,000 customers. Well-architected framework is not a new approach. It actually was started in 2012, more than 20 years ago. Initially, it was used internally by AWS solution architects who reviewed customer workloads. In 2014, AWS standardized the questions across 4 pillars. Currently, the framework has been actively developed. Well-architected continues to add more features, lenses, and integration with other AWS services. Well-architected framework is a set of questions, design principles, and best practices currently across 6 pillars. Questions will validate if certain best practice is in place in our workload or not. Alongside with pillars of the framework, there are lenses, which provide guidance with a focus on specific industry or technology domain. There are 6 pillars which currently included into AWS Well-Architected Framework. There are operational excellence, security, reliability, performance, efficiency, cost optimization, and sustainability. Probably the most important note about these pillars, that despite the ordered from left to right, and actually it's like default order, when we investigate or analyze each particular workload, there are always trade-off between pillars, and it could be different factors which should be applied to particular workload during review in order to set correct correct order of pillars, which more important for us in this particular review, or could be has less priority. Let me say several words about each particular pillar. So operation excellence pillar includes the ability to support development and run workloads effectively, gain insight into their operations, and continuously improve supporting processes and procedures to deliver business value. Security pillar encompasses the ability to protect data, systems, and assets, to take advantage of cloud technologies to improve the security. Reliability pillar encompasses the ability of workload perform it intended functions correctly and consistently when it's expected to. The performance efficiency pillar includes the ability to use computer resources effectively to meet system requirements and to maintain this efficiency as demand changes and technology evolve. Cost optimization pillar includes the ability to run system to deliver business value at a lower price point. And sustainability pillar focus on ability, it focuses on environmental impact, especially energy consumption and efficiency. As I said, today we'll put attention to reliability and sustainability pillars, and at previous seminar, we discussed security and cost optimization pillars. So a link to that seminar will be on one of the latest slides. So using this, referring to these 6 pillars, please answer the question: what do you consider the most important when adopting cloud services? Okay, thank you for answering this question. So, Igor, could you share the result to the audience? Uh, so I see that today you are like more interested in security, performance efficiency, and cost optimization pillars. Okay, as I mentioned already, we discussed it on previous seminar, and if you'd like to learn more, please uh, leave a comment in the feedback form, and probably at the next seminar we will return to these topics. Okay, as I mentioned, well, there exists such special type of well-architected approaches, well-architected lenses. So actually, it's extend the gradients offered by well-architected framework to specific industry or technology domain. Example of these domains could be like machine learning lenses, serverless application lenses, Internet of Things lenses, or software as a service lenses, financial services industry. Well-architected lenses, it's like a small version of AWS Well-Architected Framework. It contains question, design principle, and best practices that are like tuned exactly for particular industry or technology domain. It means that, for example, when we consider particular workload, for example, let's imagine that this workload for application deployed as software as a service proposition, and due to this, I use SaaS lenses for this in this review. And for example, this right now on the screen we have a question from SaaS lenses about cost, which sounds like how do you measure the resource consumption of individual tenants? Obviously, it's important questions for workload deployed as SaaS proposition, but maybe not relevant to other workloads. I already mentioned several times workload. So actually workload identified as a set of that deliver business value. So workload could be a process, a technology, an infrastructure, a team, or combination of them all. And usually it's like level of detail that business and technology leaders could communicate about. And depend on each particular review and each particular workload, we could consider like we could restrict, for example, workload exactly to technology part. But well, from my experience, it's worth to consider actually it's like in full version, because a lot of best practices is like involve people and processes, or like should be implemented actually about processes. Example of workload, for example, it could be a marketing website, it could be e-commerce website, it could be backend for mobile application, could be data analytic platforms. In order to, well, each pillar contains design principle and best practices exactly for which covers this pillar, but well-architected framework identify a set of general design principles to facilitate a good design in the cloud. So first is stop guessing your capacity needs. Before we consider this design principle, let me recall that despite AWS Well-Architected Framework could be applied to any workload, it actually cloud agnostic, it could be applied to hybrid workloads, but actually it's tuned better for cloud workloads. And stop guessing capacity needs means that if we, for example, made a poor capacity decision when deploying a workload, we might end up as sitting on either expensive idle resources or having performance issues to the limited capacity. With cloud computers, this problem could go away using scaling and elastic services. Next one, in the cloud, we will have almost unlimited services, and it gives us ability to test system at production scale, so we could easily duplicate production environment, test it, and then decommission, remove it, and we'll pay just for this small time of using it. Obviously, it's much harder to implement having on-premises workload because it's required adding some additional capacity. Next one is to automate Automation permits to create and replicate workload at low cost and avoid expenses of manual effort. You can track changes to your automation, audit the impact, and revert to previous parameters when necessary. Well, about evolutionary, as business and its context can continue to evolve, it means that initial architectural decision might like hinder the system ability to deliver changing business requirements. Cloud capabilities like automation, testing on demand, and well, huge set of various purpose-designed cloud services permit system to evolve over time so that business can take advantages of innovation and as a standard practice. Also, using cloud, we can collect data how our like architectural choices impact and affect behavior of our workload. This let us make fact-based decision and how to improve our workload. And the last one, we need to test our architecture and processes, how they perform by regularly conducting game days to simulate even in production. It gives us, chance to check our procedures and understand that, responsible teams will be like familiar what should be do when, any incident happen in real life. Also, let me say about architecture, because obviously you know that architecture has a lot of different sense, a meaning, and when we speak about well-architected framework, we consider how well an architecture is aligned to AWS best practices. It means that workload which we consider could, has architecture designed and created in different ways. So it could be, microservices application. It could be service-oriented architecture. It could be, even monolithic application. And any of this application allows to apply well-architected framework approach and check that, best practices is implemented or not. So it doesn't mean that well-architected is just about microservices. No, it's about, well, are you implemented best practices which are advised by AWS based on its experience of analyzing thousands of customer workloads. Okay, in this chapter we will speak about well-architected framework reviews. So please answer the simple question: how often are you involved in well-architected reviews? Okay, thank you for answering. Well, I see that almost half of attenders today rarely or never conduct an well-architected reviews. So probably, if you'd like to, conduct such well-architected review, you may ask Svitla to provide this service for you. So please leave a message in feedback form. Intent of review. The purpose of reviewing an architecture is to define critical issues that might need to be addressed or areas that could be improved. So the outcome of review is a set of actions that should improve the experience of using the workload. To achieve that goal, review architecture need to be done consistently. So it's not like one-time check, it should be done regularly, with a blame-free approach that encourage the team to deep dive. It should be lightweight processes that completed in like several hours. Also depend on particular workload. A session could be like split into several days or conducted in one day, but it's mostly depend on each particular like customer and customer preferences. Also, a review should be involved business and technical representative, because as we mentioned, workload doesn't include just a technical infrastructure, technical resources. It's always include process. It should be like include process and team. And well, actually, one of the most important is that it's about defining those areas which could be improved. So it's not like just attempt to find that something's wrong. It's attempt to find that something could be improved. And well-architected review contains several parts. First of them, it's AWS well-architected tool. It's a service in the cloud that provides consistent process for measuring and measuring architecture using AWS best practices. We already spoke about that we need to define workload. AWS Well-Architected Framework reviews is, provided to consistently evaluate workload against best practices. As a result of review in well-architected framework, we'll define risk which could have severity of high, medium, and low. High-risk issues, or in short, HARs, and medium-risk issues, there are like architectural or operational choices that AWS has found might result in negative impact to business. Obviously, like follow it applies from the title. High-risk issues is considered as those issues that, well, could have significant negative impact. And due to this, medium risk issues also might negatively impact business, but like to a lesser extent. The issues are defined based on responses in well-architected tool, and the corresponding best practices are widely applied by AWS and AWS customers. As a result, we then review high-risk issues and medium-risk issues, prioritize them, and create improvement plan how to address them. Review usually has three stages. First, we'll define workload, and the customer also could prepare documentation and some architectural diagrams before review. Then we need to identify core team for workload which are reviewed. We need to identify sponsor of workload and subject matter expert, which could be considered as sponsor of particular pillars. And as I mentioned, we need to scope workload because, well, it depends on business needs, terms and some other factors. It could be done in a different way. Second phase is actually review phase for conducting the actual review. So consultant from consultant services company like a Svitla provide a review, ask questions, collect answers, and define best practices which are implemented, and actually analyze which are not implemented. At the end of review, we publish a report. Then third page is improvement page, and probably it's the most important phase of review. So this phase is devoted to prioritize and define HRIs and MRIs and making an improvement plan to mitigate some of risk identified as a result of conducting review. Well, I mentioned that HRRs and MRIs, there are risks which are considered by AWS that could negatively impact your business. But idea that it depends on your business, your customer needs, well, your current stage of application, and that is why we are speaking about prioritizing them. Okay, and the risk prioritizing is the process identifying most critical risks so they can be addressed first. So priorities should be set using likelihood of a risk and potential impact it poses to organization or business. The aim to determine most to least critical rank order of identified risk. And as I mentioned, example of risk impact include, lost sales, a longer time to market, brand reputation change, corporate liability, lost customer trust, maybe some legal or regulatory issues, and so on. And the risk is identified based on business goals. Also, once again, it could be like time to market, security, reliability, performance factors, and based on these factors, we define which actually should we consider this risk as a high risk issue, or could be it removed, or we just need to like mitigate. Then we include it to improvement plan, run improvement plan. No. agreed improvement plan with the customers, then it should be implemented either by engineers from customer side or engineers from consulting partner like a Svitla. And as we spoke, review should be rigorous. So after like improvement plan is implemented, a new review should be conducted. It should check which are best practices already implemented, which are like a new or like postponed risks, and like repeat. And because we'll conduct several practice case study in two next chapters, please, I'd like to ask you just imagine workloads that you know. So it's like your workload. So please answer this question in the sense that please mark what is like type of this workload, which you could imagine, and then we will consider some best practices, and I will ask you to like define as a particular best practice applied to your workload. Okay, thank you. By the way, who mentioned that it's some other type? Please, if you don't mind, mention what type of workload you choose, because it's quite interesting for us. I will keep in mind this, ephemeral workload. It's one of project which Svitla conducted, and like in short, it's web application deployed as ECS services with the hardened and secure network. It's use security dashboards, performance monitoring dashboards. It has various integration with others, with different services, deployment development processes, use AWS backup to backup database and SS3 assets and so on. So it's okay. So let's start speak about reliability pillar. Reliability pillar, like it's a third pillar in AWS Well-Architected Framework, and as we spoke, it's always a trade-off between pillars. So reliability pillars could be considered as the most important than others due to such reasons as, for example, business continuity, customer trust, because, for example, if our system will not be reliable and stable, obviously we will lost customer trust. It could be regulatory compliance and, for example, high cost of failure. By definition, a reliability pillar encompasses the ability of workload to perform its intended functions correctly and consistently over an expected period of time. This includes the ability to operate a test workload through its total life cycle. Achieving reliability can be challenging in traditional on-premises environment due to features of traditional on-premise environment, like a single point of failure, lack of automation, and lack of elasticity. But even if we consider workload deployed to cloud, regardless of cloud provider, there are still potential for failures to impact, which could impact our workload. So therefore, we need to make steps to implement resiliency if we would like that our workload should be reliable. Design principles. There are 5 design principles in reliability pillar. First of them, it's automatically recover from failure. Well, if you don't, in order to be able to automatically recover from failure, we need to monitor our work. We need to monitor key performance indicator of our workloads that actually measure business value, not like a technical parameters. And then we may start an automation to perform specific job when this threshold is breached. We may have automatic notification and the tracking of failures and automated recovery procedures that works around or repair a failure. It allows us to anticipate and like mitigate failures before they occurred. Next principle is test recovery procedures. Despite we define these procedures, we need to check that they work, and we need to validate them. And we may do it using actually cloud services. We may, and automation, we may either like emulate different failures or just repeat the scenario which led to failures previously. Scale horizontally to increase aggregate workload availability. For it, well, works to replace one large resource with multiply small resources to reduce impact of single failure on the overload workload. If we distribute requests across multiple smaller resources to ensure that they don't share the common point of failure. A common case of failure in on-premise workload is resource saturation when the demands placed on workload exceed the capacity of that workload. In the cloud, we may monitor demand and workload utilization and automate the addition of or removal of the resources to maintain the optimal level to satisfy demand without over provisioning or under provisioning. And one more principle is changes to our infrastructure should be done using automation. Even more automation also could be like monitored and well automated. And the changes that need to be managed includes changes to automation. I guess most of you know what is a shared security responsibility model in the cloud, and obviously resiliency is also like a shared responsibility between AWS and well, us as a customers. So AWS is responsible for resiliency of the infrastructure that runs all services offered by the AWS cloud. Infrastructure comprises hardware, software, database, networking, and facilities which run AWS cloud services. And these services actually, their availability meets or even exceed AWS SLAs, which we could like include in our consideration. Our responsibility as a customers, it's actually for responsibility of what we use in the cloud. And it depends on AWS services which we use. So for example, if we like use AWS, no, Amazon EC2 service, it means that we need perform all necessary resiliency configuration management tasks. We need to spread our instances through several availability zones because they are designed to help us like improve reliability of the system in the case of some failure. But for example, if we use such, managed services as Amazon S3 or DynamoDB, we don't need to care about availability zones, but we need to be responsible for manage in the like a scope of management resiliency. We are responsible for backup data, versioning data, replication strategy, maybe even disaster recovery strategy if we'd like, for example, implement disaster recovery with moving our infrastructure to another region. There are several best practices in reliability pillars. Well, it's not much. It's actually just 4, but they are very important. So first of them is foundation. Foundational requirement actually influence reliability. Obviously influence reliability because without like a solid basement, you are not able to create a solid build and build the infrastructure. With AWS, most of these foundational requirements are already incorporated and can be addressed as needed. Despite cloud is like designed almost limitless, it's actually our responsibility. It's responsibility to AWS to satisfy requirements for sufficient networking and compute capacity. But we need to understand how it works and put effort to manage services quotas and constraints. And obviously, we need to plan our network topology in order to meet reliability requirements. Also, reliability workloads starts with upfront design decision for both software and infrastructure. For reliability, you must follow such patterns as design workload, service architecture, made decision which architecture from service point we will use, what is boundaries of our services and their functionality. Also, in this best practice include that we need to design interaction in a distributed system to prevent failures and actually mitigate and withstand failures if it happens. Change management we'll consider in details on the next slide, and failure management means that a low level failure management, once again, in cloud, it has some features because, for example, if we speak about on-premises, it means that low-level hardware component failures, could happen in on-premise data center, and we as owners of workload need to care about that. In cloud, we protected against this type of failures, but we still obviously need to implement such best practices as backup workload data, use file isolation to protect workload, design test reliability, and always plan and implement disaster recovery scenario. For change management best practice, changes to our workload and its environment must be anticipated and accommodated for reliable workload operation. Changes include those imposed on your workload, such as spike in demands. They also include internal changes such as feature deployment and security patches. You see best practices which are included into change management best practice area, and they could be split into several big groups. First of them, it's monitor workload resources, which include define and calculate metrics, monitor end-to-end tracing of requests through the system. Excuse me. Next group, it's design workload to adapt changes in demand that we need to update, or we need to obtain resources upon detection that, it's required. And the group of implemented changes where we need to use runbooks for activities. We need to integrate functionality and resiliency testing, and it's advisable to deploy using immutable infrastructure. And as I mentioned, well-architected framework contains different questions, and let us consider a question about how do you implement changes. It's included into change management best practices area, and the question sounds like controller changes are necessary to deploy new functionality and to ensure that the workload and the operating environment are running known software and can be patched or replaced in predictable manner. There are several best practices which are included to this question. So first, use runbook for standard activities such as deployment. Runbooks are the predefined procedures to achieve specific outcome. Use runbooks to perform standard activities whether done manually or automatically. Well, example could include deploying workload, patching workload, or making DNS modifications. Next best practice is integrate functional testing as a part of deployment, which actually means that functional testing should be included to deployment pipeline, and it stops when test fails. Similar one, integrate resiliency testing as part of deployment, and in this case, resiliency test should be designed using principle of house engineering. Deploy using immutable infrastructure is a model that mandates that no updates, security patches or configuration changes happen in place or on production workload. So when a change is needed, the architecture is built into new infrastructure and deployed into production. And the last one, deploy changes should be deployed with automation. in order to eliminate negative impact. So please answer on this question. So I ask you, Mark, those best practices which I implemented in workload, which I proposed you to imagine several slides before. Okay, thank you. Let's move forward. Okay, in my case, for my workload, which I mentioned, we implemented two best practices, runbook and include functional testing. Unfortunately, resiliency testing as part of deployment was not in like current roadmap. It's currently in backlog, and I believe it will be implemented later. Also, AWS provides several services which help to implement that. Deploy immutable infrastructure also not implemented. So you see on the screenshot that these two best practices are not checked. And obviously deploy everything just with automation. It's like must have, one of the probably the first principle which should be implemented in any application. Okay, and if we let's imagine that we run AWS review just for this small question, and then if we switch to improvement plan, Amazon AWS well-architected tool advised us to pay attention to medium risk issue. It's just one, not high risk issue. It's medium risk issue, and it referred to documentation of best practices, how to implement this particular two best practices. And actually, this is like a skill of consultant from consultant partner to know all this information which provided by AWS, and then define how it could be implemented to your workload. So compose roadmap, compose improvement plan agreed with you as a customer, and implement to improve your workload. Sustainability pillar, as we mentioned, it's the most recent of 6 pillars that was introduced to the framework in 2021. And as always, it could be some trade-off between pillars, and there are multiple reasons that sustainability can be an important consideration in improving architecture, like customer demand, government regulation, employee demand, or impact investing. By definition, sustainability pillar focuses on environmental impact, especially energy consumption and efficiency. Since there are important levers for architect to inform direct action to reduce resource usage. When building cloud workloads, the practice of sustainability is understand the impact of the services used, quantify impact through the entire workload cycle, and apply design principle and best practices to reduce these impacts. In the similar way, environment sustainability is like a shared responsibility between customers and AWS. AWS is responsible for optimizing the sustainability of the cloud, delivering efficient shared infrastructure, water stewardship, and sourcing renewable power. Customers are responsible for sustainability in the cloud, optimizing workload and resource utilization, and minimizing the total resources required to be deployed for your workload. Sustainability in the cloud is actually a continuous effort focuses primarily on energy reduction and efficiency across all components or workload by achieving the maximum benefit from resource provisioned and minimizing the total resource required. Let's speak about design principles. There are several design principles. So first of them, we need to measure impact of cloud workload and model the future impact of your workload. It should include all sources of impact, including impact resulting of customer use of our product and the impact resulting from their eventual decommission and retirement. For each workload, we need to establish long-term sustainability goals, such as reduction compute and storage resource required per transaction. We may achieve maximize utilization by right-sizing our workload to implement efficient design to verify high utilization and maximize the energy efficiency of the underlying hardware. It means that, for example, two hosts running at 30% of utilization are less efficient than one host running 60% of utilization because actually consumption is calculated per host. We need to design architecture in continually monitor and evaluate new, more efficient hardware and software offering. As we mentioned, when considering sharing responsibility model, sharing services across customer helps maximize resource utilization, which reduces the amount of infrastructure needed to support cloud workloads. And when we use managed services, it means that it's designed by AWS, and all questions about like sharing usage of hardware is solved and addressed by AWS. Due to this, customer can share the impact of common data center component like power and the networking by migrating workload to cloud. And reducing the amount of energy or resources required to use our services and reduce the need for customer to upgrade their devices to use our services. Best practices in sustainability pillar such as regional selection, when you need to define region where you deploy your workload based on KPIs and business needs and sustainability goals. We need to align our infrastructure and our architecture to demand, so it should be scaled to continually match user load, and we need to try stop creating and maintain unused assets. We need to make and use software and architecture patterns, which includes like using asynchronous and scheduled job. We need to refactor workload in order to remove components which are not used. Actually, we need to care about using customer devices and equipment, and design data access and storage patterns. If we move forward, in the scope, for example, in the hardware pattern, we need to look for opportunity to reduce workload sustainability impact by making changes to our hardware management practices. It means that we need to use a minimum amount of hardware to efficiently meet our needs and use an instance types which has less impact. We need to use managed services to operate more efficiently in the cloud. Next best practice area, process and culture we'll consider on the next slide, which devoted to best practices which are included in this best practice area. So process and culture best practices look for opportunities to reduce sustainability impact by making changes to development, test, and deployment practices. It includes such best practices as adopt methods and processes to validate potential improvement, minimize testing costs, and deliver small improvement. We should keep workload up to date to adopt efficient features, removing remove issues, and improve the overall efficiency of our workloads. Increase utilization of resources to develop, test, and build workload. And use managed device farm to efficiently test a new feature and represent on a representative set of devices. And accordingly to, in the similar way, let us like conduct practical case study of sustainability. So this question is about process and culture best practices, which sounds like how do your organizational processes support your sustainability goals? There are 4 best practices. If you not implemented any of them, you need to check none of those. And they sounds like what we already, recall in previous slide. So please, could you select implemented best practices in your workload, which you imagined previously? Okay, thank you for answering. Uh, in the similar way, we implemented 3 best practices that is adopt methods that can rapidly introduce sustainability improvement, keep our workload up to date, and obviously increase utilization of our built environments. We shut down it at night and could reuse it whenever it's possible. We, in my workload, we don't use managed device services for testing, but for example, you may use we didn't use. Okay. And if we analyze improvement plans that is provided by AWS, probably we'll be surprised because currently it doesn't, include any high risk issues and medium risk issues for us. Indeed, it's so because best practice like use managed, not implemented best practice like use managed device farm for testing. It's considered as low risk issue, and due to this, it's not included in improvement plan proposed by AWS. We may use different managed cloud services like AWS Device Farm and CloudWatch RAM to help implement these features. Okay, as I promised, there are several useful resources of which you could use if you'd like to learn more about well-architected framework. There are links to framework, documentation, labs, and solution library. Other links to Svitla AWS Managed Services and Solution and to our previous seminars on cost optimization and previous well-architected seminar. Conclusions. We covered a lot of topics concerning AWS well-architected framework. We discussed how to design a well-architected approach, how it could be help you find issues and as a result significantly improve your workloads. We discussed who should be involved in well-architected reviews and consider real case study techniques. Okay, if you like know more, or if you'd like to organize well-architected review for your workload, please contact us. If you have some comments or would like to learn more, please leave a comment in feedback form. QR code for this you see right now on the screen. If you'd like to learn more, about, for example, reliability, cost optimization, or any of other pillars, you also please leave a comment in feedback form, and we'll provide seminars on these topics just for you. And thank you for attending our seminar. I hope it was interesting for you. Thank you for your time. Unfortunately, we like almost run of our time, and if you have some questions, proposition, comments, and if you'd like to contact us, please leave a note about that in feedback form, which also will be sent in follow-up letter for you. Thank you once again for your attention.